This is Jenny Kunkel, and in this video we're going to take a little bit closer look at indexes. And an index is a database object that's going to improve the speed of data retrieval operations. It's also going to function similar to a book index. If we have a book index that we look up a topic in that book index, it's going to give us a page location that we can skip right to without reading through the whole entire book. An index is going to allow us to perform the same type of operation. It's going to help us locate the data, and then we can skip straight to that row without scanning and reading through every row in the table. Therefore, when we use indexes, it's going to speed up our queries, make our performance a lot better. It's going to reduce the number of disk I/O operations because we're not reading every row in the table, and it helps us to enforce uniqueness with the unique constraints. And from the unique constraint perspective, we have table primary keys, and those are going to be enforced through a primary key constraint. None of the columns that make up that primary key can be null. The values in a primary key must be unique, so it's going to be a unique constraint. And when we create a primary key constraint, it is going to generate a unique clustered index for SQL Server or a non-clustered index for Oracle on the columns that make up that key. When we are looking at creating a unique key, this can be enforced through a unique key constraint in both Oracle and SQL Server. The values that are stored in that column must be unique. And then when we generate that constraint, it's also going to generate a unique non-clustered index on the columns that make up that unique key automatically in both SQL Server and in Oracle. The one exception is the foreign key. The foreign key is going to be enforced through a constraint, but in this case, the index is not going to be automatically generated for a foreign, but in a lot of cases, we're joining tables on that foreign key. So it is a best practice to add an index to facilitate a more performant join. And that's going to be something that has to be done in addition to defining that foreign key relationship. Now, if we look at the different index types, we have indicated that SQL Server has a clustered index, and that's going to essentially sort and store data rows in order based on key values. SQL Server have one clustered index, and that's usually going to be on the primary key. Oracle doesn't really have clustered indexes. Now, with our non-clustered index, this is essentially going to be pointers to data allowing multiple indexes per table. And in SQL Server, we can have 0 to n number of non-clustered indexes. And in Oracle, we can define any index, and they're all going to be non-clustered. There are some caveats with respect to how many indexes we define, and we'll take a look at that in just a little bit. When we get into the best practices for handling our indexes, we want to make sure that we're not over-indexing a table. We don't want to, by default, go out and put an index on every column in a table because that's going to slow down our inserts and updates. If we need an index on a table because we have some really slow performing queries, then we would go ahead and put the index on the table. We just don't start out with putting them willy-nilly all over the table. We also want to regularly maintain and rebuild those fragmented indexes, and also not use indexes on small tables where we have full scans that are going to be faster. If we only have 1 or 2 rows in a table because maybe it's used as some type of a config type parameter table, then we would essentially not put a lot of indexes or any indexes on it because the full scan is going to be much quicker. Regardless of what we do, though, we always want to evaluate the impact of the modification overhead versus the retrieval benefits before adding any additional indexes. Now, if we continue on, that's essentially the end of the slide deck, but we do want to go in and look at both SQL Server and Oracle and look at the query execution plan for a query in each of the tools. Now, within our SQL Server Management Studio, we want to get into the AdventureWorks database. I'm going to go ahead and create a new query here, and I'm going to paste in the query And if we look at it, we're going to be getting the city, the state providence ID, and the postal code from the person address table as A, joining that to the person business entity address, where those two address IDs fields match, then joining that to the person table on the business entity ID, and then filtering by the first name where it's equal to the K%, so the wild card, and then also with a state providence ID equal to 9. So when we're looking at things from an index perspective, the items that we would be looking at is anything that's in the join condition. So I have address IDs, anything that is in a filter condition. So this is going to also have business entity IDs. Our filters are going to be first name and then the state providence ID. So those are going to be the filter conditions that we would essentially want to look at from the standpoint if our query performance is horrendous, that we would try to somehow tune. And that might be where we need to create a new index. It might be that we need to rewrite our query. Sometimes we have to do a combination of the both. Now, in our case, if we execute this query, the performance is not awful. And we can see that we're getting 253 rows back, and it didn't take that long to actually do. But if it did, what would we do? Now, here we have our execute. We have an option for canceling the executing query. Then we have our parse, and then the next thing that we have is to display our estimated execution plan. If we click on that, it's going to give our plan for how it is using and executing that query. So the optimizer on the database is generating a query execution plan. This is what we're seeing here, and that's how it's actually performing our query for us. This is what we typically want to target, trying to update the query execution plan to make it faster so that the costs are not so high when we are trying to execute the plan. Now we can go ahead and over each one, if we mouse over each of the individual pictures, it's going to give us a little bit more information about how it's joining the information together. We can see that hash mash. It's showing us the output list and then the hash key probes. We can take a look at the hash mash here with the hash key probe. And then down here as well, we have our output list. We have our output list here on our index scan non-clustered and then index scan non-clustered there. So we have a couple different index that we're scanning, and we can pretty much tell what index are being used. So if you look at it, that's going to be the IX_P. And if we start looking, this is going to be on the person table. So if we go to our tables and expand that, so our person.person, and if we're looking for our IX, this is going to be the IX person _ last name, first name, middle name. So it's doing an index scan on this index that we have here. If we look at this one, it's going to be doing that index scan on that IX_business entity address type ID. So if we look at our table, this is going to be the person business entity ID address. If we come over here, person.business entity address, we have our indexes. This is going to be essentially using this one here. So we can see that it's using some of those indexes that already exist. Now, one of the other things that it's doing is it's also giving us a missing index. And if we look at this missing index, it's telling us to create a non-clustered index on person.address. And if we look at person.address, this is going to give me the indexes that already exist on this table. We have the address row good ID. We have our address line 1. So this is going to be a non-clustered unique key. We also have our state province ID, and that's going to be a non-unique, non-clustered. And then we, of course, have our clustered, which is going to be the primary key. Now it's telling us to create an index on the state province ID, which we already have an index on the state province ID, and it's telling us to include the city and also if we look at this a little bit more. So we can always go ahead and look at the missing index details. It's going to give us more of the information, and to include the city and the postal code. Now, why would I go ahead and create a new index when I already have an index on that state province ID? That's what we're actually doing our filtering on. And if I would go ahead and do another one, I'm essentially going to be adding a second index where I already have one that I could use, because the state province ID is what we're actually going to be filtering on, and we already have that covered. So I wouldn't necessarily go through the process of adding a new index. I can look at the message that it generates to determine if that's something I want to do, but I should always go through the evaluation to determine whether it makes sense to add a new index. Over here, we're doing that index scan on our person index, and that is going to be on our last name, first name, middle name. Now, typically, what we want to do is we want to organize the columns in that index in the order that we always have the data present. So if we're always doing a last name search, we would have our last name column first in our index, followed by, if we have the first name most of the time after that, then we would put the first name, and if sometimes we have the middle name, then that would be at the end, because it tries to match starting at the beginning. And it's going to give us the best performance starting at the beginning of that index. Now, it is matching on that one. It's probably not the best index for it to be actually using. If we didn't have that whole entire concatenated index, we might think about trying to go ahead and creating a first name, but the query performance here is not awful, so we probably would not want to do that, because we already have something that should probably take care of most of the times that we want to search for somebody in the table. So that's our SQL Server. Let's go to our Oracle. Now, if I switch over to Oracle, I need to first get into my XE database, because there are a couple things that I need to do. Because this is a pluggable database, again, I need to alter the session before I create any changes on any permissions, and I'm going to be doing the CO account. When I do the CO account, I need to grant advisor to CO. That's one of the things I need to do. I also need to grant select catalog role to my CO account as well. And then I also want to go ahead and grant select any dictionary to CO. Now I'm going to go ahead and execute all of these commands. Once I do that, I can then go ahead and log into the CO database. I need to do this before I log into that CO database so that any of the changes I make are going to be applied. Now, if I log into my CO database, I want to execute a query, and this is going to be the query that I paste in here. And this is going to essentially be joining from the orders to the order items on the order ID field, on the products to the order items and the products table. So essentially going to be joining those three tables. So again, anytime that I have a join condition, so I have the order ID and the product ID, these should be foreign key relations that we're joining on for the most part. And then I have my filter condition for the product name. Now with Oracle, the indexes are all going to be lumped together in the indexes. It's not going to be broken up underneath each of the table instances. But if I click on a table, I should be able to see what they are. If I click on, for instance, the products, that's going to bring up everything about it. I can go over to the end, and it's going to show me that I only have the primary key index defined there on the product ID. If I go to my orders, I can see pretty much that I have the primary key. I have something on the orders table to the store ID, the orders table to the customer ID. So those are going to be indexed for those particular fields on that table. So it's always giving us the table name first and then the field name. And then for whatever reason, it's giving us an underscore I for an index, I'm assuming. Then if we go to our order items, we can see the same thing here. So that's going to give us what has been defined. Because we're looking again, do we have our foreign key set up because we're joining. If we're missing our foreign keys, we're probably needing to add an index to facilitate a better join performance. If I go ahead and execute this, it's not horrible. We can see that the way that Oracle kind of caches out these things, but it's not horrible performance, but it doesn't mean that we can't improve it. Now, one of the things that I can do is I can run the execution plan here as well, and this is called the explain plan. So this is going to be the third icon that's going to show us the explain plan. It's not going to be as pictorial in nature, but what we focus on is the cost, and that's going to be 17 for the whole entire query. When we're trying to tune queries, we try to get that number to go down. If something we do is going to cause it to go up, then we want to roll it back and put it back to the way it was. So if we're changing the query, we want to put it back to what it was originally, or if we have added an index and it goes up, then we want to remove the index. Those are the things that we look at. It's going to give us a little bit of an option to tell us how it's joining it. So we can see that that's the join condition, and we can look at the products, that object name. It's going to take us to whatever the object is. So it's going to give a little bit of information here that we can go back and forth. Now it's showing us that it is using that primary key, and then it's doing a by index row ID, and then a full table access. Full table access is not usually a great thing. If I want to think about, I have indexes. If I look over here, I have my order items primary key, so that's going to be on this here. Then I have my order items, and then my order items primary key is going to be on the order ID, so that's taken care of. I have an index there. I also have my products, and the products is going to be such that, roll down here, products. We have the primary key there for the product ID for our join condition, but maybe we want to go ahead and add an index on our product name. Let's go ahead and do that. We're going to go ahead and create the index, and we'll try to use the same type of naming convention. So this is going to be on products. That's the table name, underscore product name, and then we're sticking an I at the end. Then we specify what table this is going to be on. This is going to be on the products table, and then we are putting it on the product name field. Now when I execute this index, I've added my index. Now if I go ahead and redo the execution plan, I can see that I'm down to a 14. Now if I execute it, it may not really show much difference here as far as how it returns results. Okay, so it's not really necessarily giving me much difference as far as the time it takes to actually execute the query itself. But the relative cost that we're seeing with the explain plan indicates that it's perceived to be a better plan than what was originally there now that we've added that index to that table. We have a few other options within SQL Developer 2. One of those is the auto trace. If I need to auto trace a query, I can execute that and it will go through and do some auto tracing. Okay, because I have this on the thing, I have to actually do the query here in order to do the auto trace. And we can kind of see that it's doing some of the same stuff. It's got a little bit more information with the elapsed times, etc., and giving us a little bit more information there. Okay, so that's going to be something that gives us a little bit more information. And if I decide that I want to do some tuning, they have a SQL tuning advisor that's going to be a little bit more like what we saw with SQL Server Management Studio that gives us a little bit more feedback, but that requires an enterprise license and you would have to pay a licensing fee in order to get that. Unfortunately, there are ways to spoof it, but it doesn't work with pluggable databases. So unfortunately, we can't really do anything about that to take a look at that tool. In some cases, if we needed to, we could also rewrite a query. And in this case, if we rewrite it, it should pretty much return the same query execution plan because I don't have huge tables that I'm executing. But sometimes when we have really big tables and we need to try to filter down a table size a little bit before we join it in, the with statement sometimes is convenient for rewriting a query and having it do that. And if I execute the plan, notice that it's 14, so it really doesn't change because the size of our tables are not huge in this case. So hopefully that gives you a little bit of context on how we tune queries and indexes in general.